Hi, this is Rick from Renaissance Charge again, and this is another video that we're just going to do. The last video that we showed of this motor didn't have the heatsink on, so this is the same motor with the heatsink, and now we have actually generator coils too. Every other motor coil. So if you want to know the details of this whole system, look at the last video. I'll put a link on it so you can see. Anyway, I wanted to add this to the video, and so what we're going to do is run this with the trigger coil, or sorry, with the Opto switch inside here, as shown by these wires you'll see in the other video. So there's the Opto board. It's all hooked up, and now we have on the trigger coils, or sorry, generator coils, 100 watt LED modules here, and the difference between what we're doing with these right here and earlier videos is we have a bridge rectifier on these, 50 amp bridge rectifier, overkill, but that's what I had. And so that's important because these are really DC, or they're, I mean, they can receive an AC or a DC signal, but they really respond to properly the DC, so we rectified it. It is an AC wave coming off of this. Now, what we've done here is put a terminal block here, and all these generator coils are in series with each other, so we just went from either end. We put them together in series, and that's why you see all the mess of wires. But normally people will take these two wires, the ends, and run a load off of that. Or you could parallel them up. Just make sure they're in the right sequence from top to bottom on the coils. Alright, so we're just going to get it started here, and turning on the accessory battery. This just turns on, you can hear the tick. And that's when you really turn the power onto it. So this only gets activated when we put it, like right now the Opto is turned off inside there because it is not in the gap. So as soon as we turn it on to the gap, so you can see it's going to be very bright. The camera will probably adjust to this. So at a certain brightness it will blow out these bulbs, so we would have to be careful. I'm not going to run it too much, but I wanted to show that it is charging the battery, and I don't want to get going too fast. Well, we can push it. I've got some power adjustment here. It's only at 12 volts. Or we can turn it down. So as we adjust these resistor values, the base resistors, these branch resistors, this resistor, and so forth, then I'm going to turn this off. Well, as that is adjusted, the power level changes, of course. So what we're going to do is we're actually going to run this very easily now. We're just going to remove the Opto circuit entirely, place it over here, out of the way, and then we're going to run this as the trigger coil. So if I have the ability to do this here, okay, I can reach. So now what I'm going to do, I'm going to start off. We can turn the direction now any direction the wheel will turn, because one of these wires then, as you can see, gets bypassed and uses as a trigger coil. So that turns on the transistors just the same way. Now watch the voltage pop up higher. Oh wait, I gotta turn in this case we have a switch here that will switch it from that mode to the trigger coil mode. So I have the pot turned way up, but you can see even with very little power we have a response. So this one is not so self-starting. It's not very hard to start it, but now you'll see the response of it quite higher, as we talked about in the last video. It's going to have a tendency to push that voltage up under charge a lot faster than the other method. So what we're going to do is pop this up to speed, and be careful that we don't blow out these bulbs here. They're not properly heat sinked, of course, so we're not going to push them too high. And also that spike, or that really high voltage on them, is not very good for them. This pot has been burned out a little bit. You can feel it when I just turn it slightly. So if so what I'm going to do is turn it to the other side. Because that side seems to be a little bit burned out. It's only like so this side can handle it more. What we do is have a 50 watt resistor, fixed resistor, when we're finalize this, but I wanted to be able to adjust it for this video here. So we can see, you know, the voltages and all that. But I just wanted to show the generator coils hooked up, and that we are charging the batteries again. You know, anyway, this is 12 volts only. If you're going to spend the money on this motor as you would, you'd be pushing this at, it's really set up, the resistors and all that, for 36 or 48 volts. So I'm not going to attempt to push it fast or anything, 12 volts, because I would have to change all the resistors out. So anyway, there's a lot of adjustment to it. So again, we could just turn it off that way, because we don't have the other one hooked up. We could switch over to the other system, you know, back and forth. These produce two different types of energy though. You've got the, what we were doing right there is the negative energy output to the batteries in the pure form. And then when we do the opto switching, it's more of it's more positive energy, and that's why the charging rate seems slower. It's just actually, when we were charging it with the other method, it's actually more of the real voltage rather than this negative energy charging is, it's a little bit inflated while you're charging, because it will come back down more readily than the other one. Anyway, that's all I wanted to show for this video today, and you can hook up many other types of loads to the generator coils there, and then yeah, so thank you for watching.